Yes, ma'am, you can start.
We're live, sir. Should we start, sir?
Yes,
Ma'am,
please.
myself.
So
Okay.
will you be?
Yes, sorry, sir.
Yeah, you have something to
It's okay,
present
ma'am.
or share?
Yes, sir. I have a short introduction. Should I go for it?
Yes, please do that.
Okay, sir. Good evening and welcome to one and all. Myself, Rupsha from ClearNet, the designated station assistant for a seamless experience of the session. ClearNet is India's most trusted and widely used digital platform with multiple enriching services exclusively for doctors. And ClearNet is very proud to be a digital partner of this event organized by Indian Association of Preventive and Social Medicine. And the topic of today's session is basic concepts in biostatistics. So let's begin today's session, for which I would like to invite Dr. Animesh Jain, sir. Over to you, sir. Kindly proceed with your talk.
So thank you, Rupsha, and thank you, ClearNet, for partnering with us. Again, we are here with another session of IAPP, or Interinstitutional Academic Program for Postgraduates. This has been a flagship program which has been started long years back, thanks to Dr. Kulkarni, who's our National President-elect for IAPSM. And it was actually initially an offline program. Now, post-pandemic, we have gone online, and this has given us a far better reach. We are again here with another program today, and this will be actually a part of the second part will be next month. So two-part series. The first part today is basic concepts in biostatistics, and we have Dr. Asha with us. I'll introduce her in a while. We also have Dr. Poonam, who is the president of IAPSM Karnataka chapter. So I invite Dr. Poonam for her opening remarks. Dr. Poonam.
Thank you, Dr. Animesh. On behalf of IAPSM Karnataka chapter, I welcome all of you for this particular session of IAPP under the banner of IAPSM Karnataka chapter on basics of biostatistics. And as we understand through this IAPP platform and forum, we intend to reach out to a larger number of postgraduates, and the online modality has facilitated to reach out to a good number of postgraduates and faculty all over the country. And as we all understand, being from community medicine, biostatistics is one of the integral part that we require for each and every aspect of, let it be epidemiology or investigation or research. So with this particular importance, today Dr. Asha is here to deliver the session on basics of biostatistics. And as Dr. Animesh mentioned, there is a sequential session also for this in the next month. So I'm sure these particular, both the sessions of biostatistics would be of great importance for the postgraduates, and we look forward for a great interaction also. Thank you. Over to you, Dr. Animesh.
Thank you so much, Dr. Poonam. So we are very happy actually now the reach has become so far and wide and all over India people. In fact,
So there is some network issues, I guess.
Hello, sir. Animesh, sir, are you there? Hello, sir.
I just give him a call.
Okay, ma'am. Ma'am, can you tell me that when to paste those Google Form questions in the chat box?
Dr. Asha?
You can post it now.
Okay, ma'am. So,
Yeah.
okay. Okay, ma'am.
Yeah, Animesh has left the meeting. I think he will join back. Maybe he's lost his connection. Dr.
I have
Animesh,
posted
lost
the
the connection. Oh, yeah, right. Now it is, we do not see you in the meeting. Yes, yes, sure.
So,
So we are sorry for the technical error. Dr. Animesh has some technical glitch on his side. I think we'll just wait for a minute for him to join back, and then we'll proceed with the session. Dr. Asha,
Yes, ma'am.
so regarding the link, we would be mentioning later, right? Once you start your session, you would
Actually,
be.
I'm wanting to do it before the start of the session. So I was, I
So
just
till
want to
Dr.
be able
Animesh joins, should we mention that they can fill the Google form?
Yes, ma'am. Or
Shall I mention?
it's okay if at all the chat box, they can actually fill it also so that we can have a discussion at the end.
Okay, so shall I ask to fill the
Yes.
Google form?
Yeah, ma'am, it's already there in the chat box.
Yeah, that is what.
Yeah.
So, yeah, so all the participants are requested to fill in the Google form that is posted in the chat box. So it comprises of a series of questions with respect to biostatistics that Dr. Asha has framed so that she knows the level of understanding, the present knowledge of the postgraduates, and she can take it further. Yeah, Dr. Animesh is back. So, yes, Dr. Animesh, over to you.
I'm very sorry. Something went wrong and technical, issues. So yeah, I was just talking about. So yes, we are back here, and since we've lost time, so I'll quickly introduce Dr. Asha, who's the resource person for us today. So Dr. Asha currently is associate professor at the SS Institute of Medical Sciences and Research at Davangere. And Dr. Asha has completed her MBBS from WIMS Ballari as well as MD Community Medicine from Mandya Institute of Medical Sciences in Mandya. She was a rank holder at the university level when she completed her MD. And she's been very passionate and interested about research methodology and biostatistics. She has had numerous presentations all around. She's also been awarded for best paper in CatchCon, IAPSMCon in 2022-23 as well in uh, various other levels she has presented. And she's also got 25 or more publications in various peer-reviewed and index journals. Her field of interest is child obesity, research methodology, and statistics. And she's also had a book which she has authored on childhood obesity. So with that brief introduction, let me hand it over to Dr. Asha. Let me also tell you that she's also the joint secretary for this year of IAPSM Karnataka chapter. And we are looking forward for the conference in the her institute, which is coming in the next year. So over to you, Dr. Asha.
Thank you, sir. Thank you, sir, and thanks IAPSM Karnataka State Branch for giving me this opportunity in taking today's session. So shall I share the screen now?
Yes, I think so. Do you have the thing?
Yes, sir.
Yes, please do.
Is the screen visible?
Yes, it is. It is.
Today's session will be on basic concepts in biostatistics. As Dr. Animesh Jain already has told that this session will be taken in two sections. In today's section, I'll be covering mainly on basic concepts in biostatistics. So let us see what will be there in today's session. So in today's session, we'll be learning about what is biostatistics first thing. The second one is difference between data and information. And then we'll go with types of data, presentation of data, and distribution of data. And finally, we'll solve some MCQs related to today's session. The MCQs are already posted in chat box. I kindly request all the registered people to fill it so that the basic knowledge about biostatistics will be known, and then at the final we can actually have a discussion on these MCQs. Going further, to begin with, let us see what is statistics and biostatistics. So as we all know that statistics is a broad discipline which involves collection, analysis, interpretation, presentation, and organization of data. Whereas biostatistics, it is a specialized branch of statistics under statistics that specially deals with facts which are related to biological sciences. So here it's mainly the numerical facts again, but they're related to biological sciences. Again, the same steps will be involved here, like collection, analysis, interpretation, everything will be the same. But here the main concentration will be on biological sciences. So we use biostatistics in many ways, like mainly we use it for describing the biological characteristics the first thing, and then even we use it to find the significant differences between the continuous variables, or to find the association, and even to predict the health outcomes. Like that, we have many uses of biostatistics. Some of them are listed out here. Now moving out. Yes. Now we'll come to the main thing, data versus information. So what is data and what is information? For any project or any research to be carried out, we have to collect the data. So let us see what is this data and how it is different from information. So data as definition goes like this. It is a raw or unprocessed facts which does not carry any specific meaning. So it might be numbers, names, text, anything. So it does not have any meaning at all. Whereas information, it is an organized and processed form of data. So what does it mean? Let us see this with an example here. Now I have a set of numbers which represent age of 20 study subjects. So if I look at this jumbled numbers, what I can understand is one person is aged 5 years, one more study subject is aged 7 years, and so on. So as a whole, if I want to tell something with this table, I cannot tell anything. It is just like set of numbers for me. So now let us look at the second table now. So if I look at the second table, what I understand is 9 study subjects were aged less than 10 years, 3 were aged less than 10 to 15 years. So now we can compare between the first table and the second table. So we can clearly understand what is there in the second table. So the second table, what we have it in organized form is called as information. So converting the data to information is very crucial because it helps in understanding the numerical facts better. So the data is different, and when it is being processed and it's being organized in a meaningful form, then it becomes information. Going further, this is one important slide where we have to understand the types of data, because the whole session is mainly dependent upon understanding the types of data. So depending on the nature of the variable, data can be classified into qualitative data or quantitative data. So when the data describes the quality of the variable, it is considered as qualitative data, means it's usually descriptive in nature and it is not number based. Example, gender, or it might be race, religion. So we have, it's not like number based, only the description of the characteristics will be there. Whereas on the other hand, we have quantitative data. So the quantitative data is the data that can be counted or it can be measured. It is mainly number based. So further, qualitative data can be divided into nominal or it can be divided into ordinal. So nominal data is also called as labeling variable, or it's also called as a naming variable, because here it shows the names of the variables. Like and then one more thing is here there will be no predetermined rank order or no natural order. Whereas in the ordinal data, so there will be a predetermined or a natural rank order. For example, nominal, we have an example of race, like Indian, non-Indian, boy, girl, like that. But whereas in the ordinal, we have an example of socio-economic status. In socio-economic status, we have class 1, class 2, class 3, like that, or stages of cancer, stage 1, stage 2, stage 3, or ranks in a class, first rank, second rank, third rank, and so on. So whenever there is an order, we call the data in as ordinal. So the major difference between nominal and ordinal is the difference is the order. If the data has an order, it becomes ordinal, and if the data doesn't have an order, so then it becomes nominal data. Now let us look into quantitative data, which is very important one. So the quantitative data can be divided into discrete, or it can be even classified into continuous data. So when the data can be counted, it is called as discrete data. Whereas if at all the data can be measured, then we call it as continuous data. This is one difference. The other difference is discrete data will be a whole number, whereas continuous data can be a whole number or it can take a decimal form also. Example again, like number of deliveries in a hospital per year. So we can tell it is 5 deliveries. We cannot tell 5.5 deliveries. So this is the discrete data. Or number of students in a classroom. So again, it is the whole number which gives a meaning. If we put a decimal, it doesn't give any meaning. So that is a discrete data. So for continuous data, anything like height, weight, blood pressure, RPS, hemoglobin, so these come under continuous data. Further again, continuous data can be divided into two types again, interval and ratio. So the major difference between interval and ratio is the zero that it carries. Like usually when you say zero, it means that nothing, nil. But in interval data, the zero has a meaning. Like for example, temperature. If I say 0 degrees Celsius, even that 0 degrees Celsius has some meaning. It doesn't mean that there is no temperature at all. So it gives me some meaning with zero value. Other examples, what I can quote is pH, IQ, then longitude and latitude, that's the equator and prime meridian, and time. If I say 5 o'clock, 500, the 00 has meaning in it, like 5 o'clock has a meaning. So if the 0 gives us some meaning, so then that data will be called as interval data. And if the 0 has its original value, like 0 means 0. So if I say height is 0 centimeter, it means no height at all. If I say 0 weight, it means no weight at all. So if the 0 has its own original meaning, then it is ratio. But if the 0 carries some meaning or some weightage, so then it becomes interval data. But in the slide, I want to focus that if at all for any statistical test or any chart to be applied, the main points what we have to concentrate is on whether it is qualitative or quantitative data, and then in quantitative data, whether it is discrete or continuous. This nominal, ordinal, interval, and ratio is just an extra classification, what I've just discussed. But the main point, what we have to identify is whether it is qualitative, discrete, or it is continuous type of data. So we have the next slide showing the presentation of pemphigus vulgaris patients. Let us revise what we taught in the previous slide. So here, nominal data is gender, male or female. There is no rank here. The next nominal data, what we have is involvement of mucosa, S, whether there is involvement of mucosa or no involvement. Again, there is no order. Then the ordinal data here, what we have is severity. So if you look at the pemphigus vulgaris patient, the severity is being graded as mild, moderate, and severe. So there is a rank. So that's why it is an ordinal data. Then looking at discrete data, we have number of lesions. So 2 points, it should be a whole number and it should be countable. So we cannot measure, but we can count the number of lesions. And then for continuous data, we have age and we have duration of lesions, which can be measured and it can form, or it can take a decimal form or it can take a whole number. Next, moving further, we'll see why this identification of type of data is important. As I've been saying that the identification is very important. There are 3 important points why we have to identify the data. The first thing is it helps us in further analysis of the data. Like for example, whenever we have this qualitative data, usually it is measured in terms of proportion or frequency. And if it is a quantitative type of data, it is expressed in terms of mean, median, standard deviation, or interquartile. So see what type of data we have, and then it should be expressed accordingly. The second important point is in selecting the data presentation method. Yes, so we have many visual presentation methods like pie chart, bar, line graph, scatter plot, box plot, many things. So first thing is we need to identify what type of data it is, and then we have to choose the right type of graph. So that is the second point. And third point is in selecting the statistical test. Yes, this is very, very important. Whenever we are choosing a statistical test, there are 2 things that we have to see is what type of data it is, and then whether the data is normally distributed or not normally distributed. This section, the statistical test section, I'll be taking in the next section, session. So here in this today's session, I'll be concentrating on data presentation method. So as I said, statistical tests, we have many statistical tests like chi-square, Macklemore, ANOVA, repeated measures of ANOVA, t-test, unpaired, paired, Macklemore, many things. So we have to see what type of data it is and whether we are looking at association or whether we are looking at the difference between the means. So depending upon that, we have to choose the test. till now, we have understood what is data, the difference between data and information, types of data, and why identification of the type of data is important. Now we look into presentation of data. How can we present the data? So we can present the data in many methods, but why should we present? We have to present the data. It should be in a simple, concise form so that it will arise an interest in the reader. So presentation of data is very important because it helps us in better understanding. It provides first-hand information. It helps in further analysis, and then it is attractive also. So there are many reasons why we need to present the data, and the next one is how to present the data. Is we have three main methods how we can present the data. The first one is textual form, the second one is tabular form, and the third one is in a diagrammatic representation. Let us see each one of these methods. And one point I want to focus here is we have seen students presenting their data in all the three forms, like especially in the dissertation. They present the same data in a tabular form, then they depict it in a graphical representation, and again they write a paragraph about what is there in the table or what is there in the chart. It is not necessary that the same data be presented in all the three forms. So any of the form is enough. Usually table or diagram is usually preferred, and they will be usually self-explanatory. If at all you want to focus something or you want to point out something from the table or the chart, then only we can use this textual methods. That is, I mean, what I want to say is don't fill your papers with all the three presentation methods. Choose appropriately what type of presentation method you want it for your data. So let us look at the first method of presentation of data, that is textual form. This is considered as one of the raw and vague form of presentation as compared to all the three methods. This is used only when the data is not too large because it is often time consuming. It doesn't give us a bird's eye view. It is not suitable for quick decision making, and it is not attractive also, like, as compared to tabular or diagrammatic representation. It takes a lot of time to create it and also to understand what is there in the text form. For example, here I've written it as average age of onset of diabetes is 48 years. We have a very simple data and it's very short data what I have. So I know it's not necessary for me to frame a table or to put a graph for it. So it's just a simple information what I have. So when we have such less data, then this textual form is preferred. Or when we want to highlight some points with reference to table or diagrammatic form, then we can add this textual form. Next, moving to tabular form. So this tabular form is considered as a systematic and logical arrangement of the data, which is arranged with respect to rows and columns. So when we choose tabular method for presentation, we need to look at certain points. Here I have given a graphical, the table format, how it should be there. So any table, whenever we frame, it should carry a number, it should carry a title. The title should be brief and self-explanatory. It should not be too lengthy. It should be short, brief, and it should be self-explanatory. The table should not be too large again. It should not fit into full 1 page or 2 pages continuously. So it should be short and brief. The headings of rows and columns should be clear and it should be concise. So it should be self-explanatory. And if needed, footnotes can be added to the tables. So these are some of the points which we have to focus when we are framing the table. So this slide displays a simple table which has only one variable. We have gender as a single variable here. So when we have single variable, a simple table that holds, you can note that there is a table number, there is a table name, the columns and rows are also, the headings of the columns and rows are also mentioned here. Next, we have a cross table. When we have two or more than two variables, then we can go for this cross table. This is just an extension of the simple table. And again, the same thing, table name, table number, headings of rows and columns should be added, and the table should be small and it should be self-explanatory. If needed, if we can add footnotes here. The third method of presentation of data is visual method. As compared to text and table form, this is the it has many advantages, like the visual method of presentation is attractive. It gives a bird's eye view. It's easily understood by common men. The impression created by them is long lasting. But there are again certain points to remember when we choose visual presentation. The first thing is choose the right form of graph. Yes, the first very important point is you have to choose the right form of graph depending upon the type of data what we have. As I said, see whether it is quantitative data or whether it is discrete data or whether it is continuous data. So no need to bother about nominal, ordinal, and all. But main thing what we have to see is whether it is qualitative data or quantitative data. In quantitative again, whether it is discrete data or whether it is continuous type of data. The second important point is the graph should have a title and number. Yes, like that of the table, even the graph should also have a title and it should also have a number. The third point is selection of scales should be appropriate. It should be appropriate and should be mentioned even in the charts also. Let us see that some commonly used graphs. So these are some of the commonly used graphs. What we have is bar graph, histogram, frequency polygon, pie diagram, line graph, scatter plot. So let us see each of these graphs with some important points related to these graphs. The first one what we have is bar diagram. Bar diagram is the most common form of graph used. So bar diagram can be used only when the data is of qualitative type, or we can use it only when the data is in discrete type. So either qualitative or discrete. So when the data is of either of these characteristics, then only we can choose a bar diagram. So in bar diagram, the variables, that's the independent variable, will be represented on x-axis, and the dependent variable, either frequencies or percentage. Usually the numerical facts will be represented on y-axis. The length, the bars will be of equal width and there will be gap between the bars. So these are some of the conditions that we should note whenever we are choosing the bar diagram. So there are different types of bar diagram: simple, multiple, and then stacked. So when we have a single variable to be presented, simple bar diagram is enough. So here we can note that the severity of the disease is mentioned on the x-axis and the numerical data is presented on y-axis. So point to note here is the numerical facts, either it can be percentage or either it can be frequency. Anything we can present it with bar diagram. So that is one of the advantages when we are using this bar diagram. You can note that the width of the bars are of equal length and there is a gap between the bars because this is a discrete type of data what we have. So this is a qualitative type of data what we have here. The second type of bar graph, what we have is a multiple bar diagram. When we have two variables to be represented on the diagram, then multiple bar diagram can be used. Here in this table, we have two variables, age and gender. So both of them are represented on x-axis and the numerical facts are represented on y-axis. Similarly, when we have two or more, instead of multiple, we can go for stacked bar graph. So in the stacked bar graph, instead of placing the bars side by side, we will be stacking the bars one above the other. So this is stacked bar graph. We have one more concept called as proportional stacked bar graph, where instead of representing the actual numbers like 1 and 1, so we can convert them into proportions and then we can present it here. So this is called as proportional bar graph. One more advantage of bar diagram is when we have multiple options quoted by a single study subject. Like for example, if here I'm looking for risk factors for hypertension, and a single person can have multiple risk factors. Like he might be obese, he might be having a family history, or he might be a smoker. So when I have multiple options getting from a single person, so then the ideal one to represent it in a visual form is bar graph. We cannot represent it in pie chart or any other chart. When we have multiple options, the bar graph is the ideal one to represent the data. Moving further, we have the second graphical representation. It's histogram. Like I said, in the bar graph, whenever we are presenting, it should be either qualitative data or it should be discrete data. But when I have a continuous data, for example, here we have temperature, which is a continuous data. So when I have a continuous data as an independent variable, then I'll go for histogram. So here, this is a graph, and then you can note that there is no gaps between the bars because this is a continuous data. And when the midpoint of the class intervals are joined and we get a curve, this is called as frequency polygon. Let us see the difference between bar graph and histogram. 2 points. The first one is in the bar graph, it can be represented when we have categorical type of data. That is, it can be qualitative data or it has to be a discrete type of data. When we have continuous data, we have to go for histogram. The second point is In bar graph, there will be gaps, whereas in histogram, there will be no gaps. It's moving to third visual presentation. It is a pie chart. If you see this table, this is the same table which we have used to draw a simple bar graph. Instead of simple bar graph, I can even draw a pie chart also. So what makes a difference when I choose a bar diagram or a pie chart? So both the charts can be used, but the main difference between bar diagram and pie chart is in pie chart, the data has to be presented in percentages only, whereas in bar diagram, we could have presented it either in frequencies or percentage. But here, when we are choosing a pie chart, so then the data has to be presented in percentage, because the entire circle, it represents the total data and the components of the data here, like mild, moderate, and severe, whatever we have. So that will be shown as sectors, which are cut inside the circle. So when we are supposed to draw the pie chart, the first point is we have to draw this vertical radius or a line at the top of the circle, and then the sectors should be placed in clockwise direction according to their descending order of magnitude. For example, here we have this mild grade, which is 56%, which is higher in magnitude. It is followed by moderate and severe. So the sectors should be cut in such a way that it should start from the vertical radius at the top, and then it should go in the clockwise direction. The next graph, what we have is a line graph. So line graph is used to present mainly the data which shows time trends. So here we have the data of number of admissions of psoriasis patient in a year. So when line graphs has to be plotted, the time trend has to be plotted on x-axis, and the numbers have to be plotted on y-axis. So when we are choosing line graph, see that if at all the data is showing time trends, then only we have to choose this line graph. The other type of presentation what we have is a scatter plot, which is also one of the commonly used visual presentation methods. So this type of graph is used when we have both dependent and both independent variable as continuous variable. For example, here we have height and weight, both are continuous variables. So when I want to see the correlation between these two continuous variables, then I choose this scatter plot. So each dot on the scatter plot, it represents two things. So here if you see that this dot is representing height of 87 centimeter and 10 kg. The next dot is representing height of 98 centimeters and 9 kg. So scatter plots help us to mainly understand the correlation between two continuous variables. When we have two continuous variables, the ideal graph, what we should choose is a scatter plot. After looking at the presentation, how we are going to present it, let's move to distribution of data. So this is also one important concept, and sometimes I feel it's difficult to understand also because it's more of theoretical part than practical aspect. So before analyzing any data or applying any test, as I said, when we're applying any test, 2 points have to be remembered. The first point is decide what is the type of data what we have, qualitative or quantitative. And the second point, what we have to notice, whether the data is normally distributed or not normally distributed. So that is why it is very important to understand how the data is distributed. So what do we mean by this distribution of data? The distribution, it refers to how the data is spread out or it's clustered around a certain value. There are many types of data distribution. Each one of it has its own unique properties. But here in today's session, I'll be sticking on to three major distributions: normal distribution, binomial distribution, and Poisson distribution. So in nature, whenever we have a continuous variable, like it might be height, weight, RBS, hemoglobin, or any lab values. So if at all it is a continuous data, in majority of the cases, it will follow a normal distribution. Majority of the cases, whatever variables, biological variables we take, so many a times it follows normal distribution. Second one, if at all we have a discrete data, so and it is a common occurrence, then it might go for a binomial distribution. And if the occurrence of the event is very rare, then it can go for Poisson distribution. I'll tell about this binomial and Poisson and the normal distribution in the next slide. But at this point of time, I want you all to understand that when we have this continuous type of data, so the data the distribution method, what it can follow is the normal distribution. When we have a discrete type of data, it can follow either binomial or Poisson. As I said, there are many distribution methods, like we have log normal, chi-square, exponential. Then we have the chi-square distribution, student distribution, then hypergeometric, geometric distribution. Many distributions are there. But with biological sciences, these three distributions are very important, and we'll see each one of this in the next slides. Let us move to the first normal distribution. And this is one of the important distributions because many statistical tests have been designed based on this normal distribution. Normal distribution is also called as Gaussian distribution, and sometimes because of the shape, it is also called as bell curve, or it's also called as normal curve. This type of distribution is seen when the data is continuous. The first point to remember, normal distribution applies holds good only for continuous type of data. And here in the normal distribution, the data will be clustered around certain value, and the certain value usually it is called as a mean, and that will be located at the center of the curve. So usually take anything, like it might be like, as I said, any continuous variables. So usually the variables will be clubbed, or it will be clustered around certain value. So, and that certain value, what we call it as a mean, usually that takes, usually it will be at the center of the curve. And only some values fall above or some values fall below. Like for example, in a classroom, when we see this exam scores here, most of the students, they have scored around 50%. Only some students, they have excelled and they have got A+ grade, and some students, they have scored very less marks and they have failed. So this type of distribution holds good for almost all the types of continuous data in the nature. Now, as we have understood what is normal distribution, and it is the most common distribution, let us see two important parameters, mean and then standard deviation. By now, we have already understood what is mean. It is a value where all the other data will be clustered around. So now, what if I decrease the mean, or what if I increase the mean? So if I decrease the mean, so we can see in the first set of graphs. So if I increase the mean, if I decrease the mean, the curve will move towards the left side. And if I increase the mean, the curve will move towards the right side. So what does it show me? Because why does it move? Because all the other data will be clustered around the mean. So whenever I move the mean, definitely all the other values will also move along with the mean. So mean helps me, or mean tells me about the position of the normal curve. So when I say mean, so it mainly tells me where the normal curve is located. The next one, what we have is standard deviation. So here, if you see the standard deviation, if I increase the standard deviation, the curve flattens. And if I decrease the standard deviation, the curve, it increases in its length. So standard deviation, it helps me to know the spread of the data. So when I decrease, it is almost inversely proportional to the length of the curve. As I said that when I have a small standard deviation, you can see that there's a low variability and a high consistency. When I have a large standard deviation, it means that the values are scattered. So there is a high variation and there is a low consistency. So why does this happen? Why does I mean, when I increase or decrease the standard deviation, why does the shape of the curve also changes? This is because normal curve is a density curve. So when it is a density curve, definitely the area has to be 100%. So any change in the height of the curve, it has to be compensated in the width of the curve and vice versa. So if I see the previous slide, so the first group of curves, what we have different mean, but the standard deviation is same. So that's why the width and height is same. But in the second set of graph, the mean is same, but the standard deviation is different. So then when the mean is same, the curves are located one above the other. I mean, it's the position is same here, but because the standard deviation is different, the shape of the curve is different here. After understanding mean and standard deviation, so let us understand the characteristics of normal curve, which is one of the important slides again. So the normal curve is a bell-shaped curve. It is unimodal. It means that the distribution, it has a single peak. So there will be no two peaks. It is a single peak, and it is symmetric. It means that the normal curve can be cut into two equal halves. So it's like a mirror image. Mean and standard deviation, they characterize the normal distribution. Mean tells us about the location. We discussed in the last slide. Whereas standard deviation, it tells us about the spread of the curve. So these are the two main parameters to determine the shape and position of the normal curve. The notation is given this way, where it looks scary, but it is very easy to understand. So it says that for the x variable, it might be anything again, it might be any continuous variable, height, weight, anything. For that x variable, it follows normal distribution, that is n, where it has the mean of mu and standard deviation of sigma. So this mean and standard deviation, it can take any numbers depending upon the values of the normal curve. And then the lines on either side, if you see at the tails of the normal curve, it does not touch the x-axis, so it goes to infinity. And all mean, median, and mode will be same, and it will be at the center of the curve. The total area of the curve will be 100%. And one more point is, the curve lies usually at the position with mean 0, and it will have a standard deviation of 1. I've forgotten to mention that point. Next, after looking at the properties of normal curve, one more important thing to understand is 68, 95, and 99 rule. Many times you have heard about this 68, 95, 99 rule. Let us understand what is this rule. What does this rule say? As we know that majority of the values, they lie or they cluster around mean. So the question now is, how much of it they cluster around the mean? So we know that all the values, they cluster around the mean. Whenever I shift the mean, all the values will also be shifted there. So now how much of the values will be clustered around the mean, or how much of the values will be scattered, or away from the mean? So this 68, 95, and 99 rule explains us about mainly the spread of the values. So it is mainly based on, again, two things, two parameters, mean and standard deviation. So what is this 1 standard deviation, 2 standard deviation, and 3 standard deviation? What does it say? So if I say 1 standard deviation, it means that 68% of the observation, they lie within 1 standard deviation of the mean. If I say 2 standard deviation, it means that 95% of the observation, means if I have 100 values, 95 people or 95 values will fall within this 2 standard deviation. And then if I say 3 standard deviation, it means that 99%, almost all values will fall under this standard deviation. Let's understand this again with an example. Here we have an exam scores of set of students where the mean marks is 60 and standard deviation is 5 marks. So now we have plotted a normal curve with the mean of 60 and we have a standard deviation of 5. Now the question is, how many students have scored below 60 marks? Now we know that 60 is the mean and it is taking the center position. And by the properties of the normal curve, we know that the normal curve is symmetrical in shape, means half of the values will be below the mean and half of the values will be above the mean. So now we can easily say that 50% of the students had marks less than 60. Similarly, the next question, if I want to know how many students have scored between 50 and 70, if I look at 50 and 70, this is covering 2 standard deviation, right? So 2 standard deviation says that 95% of the students, I mean 95% of the observations will fall within 2 standard deviation. So I mean to say that 95% of the students will have marks or had marks between 50 and 70. Next question is, how many of the students have marks between 60 and 65? So 60 and 65, it is constituting to half of 1 standard deviation. So 1 standard deviation means 68%. So when we have half of it, then it means that 34% of the students will have marks between 60 and 65. Now I've been saying about normal distribution. Now, how to detect whether the data is normally distributed or not? So we have two methods. One is visual method and one more is normality test. Usually normality test will be applied to check whether the data is distributed normally or not. And we have many tests. And among tests, the important ones are Kolmogorov-Smirnov test, Lilliefors corrected case test, and Shapirov test. So these are the main 3 tests which we will be using to test whether the data is distributed normally or not. And about this normality test, again, I'll be taking the next session. In today's session, I'll be talking about visual methods. Even some visual methods like the diagrams also help us to know whether the data is distributed normally or not. So what are the visual methods what we have? We have the histogram, the basic one, which help us to understand whether the data is distributed normally or not. The second one, what we have is the stem and leaf plot, box plot, PP plot, and Q2 plot. Let us see each one of these diagrams and let us see how they help us in understanding the data distribution. When the continuous data is plotted on a graph, so we see a bell-shaped curve. any skewness, if at all any skewness is there, so definitely it will show me, or it will tell me that the data is asymmetric or it is not normally distributed. You can see that in the center graph is normally distributed, and we have a bell-shaped curve. When the data is not normally distributed, there will be skewness either to the right or either to the left. So this is one commonly used, or to say by visual method, we can assess whether the data is normally distributed. But usually visual methods will not be applied because of subjectivity. So sometimes we will not be getting exactly bell-shaped curve. Sometimes someone might feel that it is bell-shaped, and someone might feel that there are outliers also. So it's better to shift or to apply the normality test rather than going for the visual methods. Next one, what we have is stem and leaf plot. So here we have a set of numbers. So here the digits in the tens place will be taken on as a stem component, and the digits in the unit place will become leaf components. And if the data shows bell curve pattern, then we can say that the data is not normally distributed. This is not the commonly used method because it is cumbersome to be plotted. The third one, what we have is the box plot. This is also called as 5 number summary because it gives me values of 5 numbers. It gives me the value of the graph itself gives me the value of median, upper quartile, lower quartile, then minimum and maximum. So 5 values will be given with the box plot. When the data is normally distributed, we will have box plot with equal boxes and equal length of whiskers. So this is a box and these are whiskers. So when we have a normal distribution, we can get a box plot with equal boxes and equal length of whiskers. But when the data is skewed either to right or left, so then we can see unequal boxes or it might be unequal whiskers. So even if the boxes are equal, if the whiskers are of unequal length, then we have to tell that the data is not normally distributed. The next one, what we have is a Q2 plot. It's also called as quantile plot. It is nothing but a scatter plot where the scatter plot is drawn by using quantiles against each other. So when it is normally distributed, we have to get a rough straight line. If there is a deviation from the straight line, then we can tell that the data is not normally distributed. The similar way, we have this PP plot. Even it is also same. If you get a straight line, when it's also called as probability plot. When we get a straight line, we can tell that it is normally distributed. Let us move to one more concept, standard normal variance. So in the normal distribution, whenever we see about this, so we understand what is normal distribution, then we understand what is 68, 95, 99 rule. And after that, we will definitely have the standardization. Many times we often find it difficult to understand what is the standard normal variant. Hope in today's session, I'll make you understand like what is this standard normal variant. So by now we have almost understood that any normal curve, it is being determined by 2 parameters, mean and standard deviation. Mean tells us the position, standard deviation tells us the spread of the data. So now let us look at an example. The same person's height, it can be measured in either of the ways. Like it can be measured in centimeter, it can be measured in meters, or it can be even expressed in inches also. As an example, the birth weight of an infant can be recorded as grams, or it can be expressed in kgs, or it can be expressed in pounds. If we look at the numbers and the units, whenever I'm changing the units, means if I'm changing from meters to centimeters or inches, the number is also changing. Similar way for grams, kgs, and pounds, whenever I'm changing the units, even the numbers are also changing. So I don't want this effect of measurement to have its effect on the numbers. So that's why I want a unit-free form. So how can we get this unit-free form? So for this, we have to standardize the data. So this, to eliminate the effect which is produced by the choice of units of measurement, the data needs to be converted to unit-free form. So we don't want any unit to come into the picture. Or in other words, what we want to say is we want the data to be normalized, or we want the data to be standardized. For example, here if you see in the first curve, the mean is 1010 and the standard deviation is 20. So if I change the units of measurement in this, so definitely the numbers will also change. So I don't want it to be expressed in this way. What I want it to be expressed in terms of mean of 0 and standard deviation of 1. So how do we standardize it? We standardize it by using this formula. Z is equal to x minus mu divided by standard deviation or sigma. So all the scores, whatever I have, so that I'll be placing here, and then Mean will be subtracted with the scores that will be divided by standard deviation. So when we divide it, we'll be getting the z-scores. So what does this z-scores indicate? The z-scores indicates the distance of the value. So whatever values we have, so we will come to know how far this value is from the mean. But here we'll be measuring in terms of standard deviation. So we will not be measuring in terms of any pounds, kgs, nothing. But the measurement, whatever we have, the measurement will be in terms of standard deviation. Real-time example, we have often seen these scores in growth charts. So this is how we get the z-scores, the standardized numbers. Let us understand this again with an example here. Here we have a set of marks which are scored by students when the test is conducted to them for 60 marks. So if you look at it, many of the students that have not scored above 30, means if I just look at the marks and then if I put 50% as an average to pass them, so what I do is I'll fail all of the students. So this might be a tough test. So what the teacher decides is he decides to standardize all the marks, and then he decides that he wants to fail the students who will score less than 1 standard deviation. So now when we have standardized all the scores, these are the values what we have got, and the same numbers are being plotted here in the graph. So only 2 students have scored less than 1 standard deviation. So only these students will be failing now. I think this is fair now, failing 2 students rather than failing a large group. So when we have these numbers, there is a lot of confusion, and the prediction or the representation of it will be difficult. So that's why we have to standardize it, and then we standardize it with a unit-free form, and then we have to take the decision. So now let us move to a discrete type of distribution, binomial distribution, and then we have Poisson distribution. So binomial distribution. This is also called as Bernoulli's distribution. 3 points to note whenever we want to say that the data is following binomial distribution. The first important point is see whether the data is discrete or not. The data has to be discrete to follow binomial distribution. And it is applied only when there can be 2 mutually exclusive results. Like when I flip a coin, I might get head or no tail, fail, pass, deceased, non-deceased, anemic, non-anemic, diabetic or not diabetic. So only 2 options are there. So it should be mutually exclusive 2 results. So, and then the third one is the specific number of trials should be known. We'll understand this with an example here. But before that, I want to again point out or stress on these 3 points. The first point, discrete data. The second point is 2 mutually exclusive results. And the third one is the specific number of trials should be known. Now I have an example here. Let us, I want to flip a coin now 2 times. I want to flip a coin 2 times, and I want to know how many times I would get head as an outcome. So number of times I'm flipping a coin is 2, means the number of trials is 2. What is the expected outcome? What I'm guessing here, I want head as the outcome. I don't want tail. So head is my possible outcome. If I get tail, it is that like failed outcome. The third point is mutually exclusive. So definitely either I should get head or tail. So there are only 2 options. I cannot get any other options either than head or no head. So when I look at the table, when I have flipped the coin 2 times, I have 4 possibilities to get the head. So I might get heads in both the flips. I might not get head in both the flips, or I might get head in any of the flips. So there are 4 possible outcomes. Like chances of me getting the head both the times is 25%. 25%. Chances of me not getting the head any time is 25% again. And chance of me getting head in any of the flip is 50%. The same is here, same with the desired outcome. And the probability is plotted in the form of bar graph. So when we plot it, it appears this way. So we can see that the number of success or the number of head is plotted on the x-axis and the probability is plotted on the y-axis. So this is a chart where you can see that the number of trials, what I mean, I have flipped the coin 2 times and the probability is 50%. Whenever I'm flipping a coin, there's 50% chance that I might get head or I might get tail. So probability is 50%. Now let us see what happens if I increase the number of trials. So if I increase the number of trials, means if I, instead of flipping the coin 2 times, now I'll flip the coin 10 times, keeping the probability same. Means I have if I flip the coin 10 times or 100 times, definitely the chances of me getting ahead will be 50%. So what I have done is, here is, instead of flipping the coin 2 times, I've increased my number of trials. I've increased it to 10 times. So if I increase the number of trials, and then you can see that the curve, whatever I'm getting, it resembles a normal curve. So what I want to say here is, a binomial distribution can become symmetrical when the number of trials is increased with probability of 50%. So with probability of 50%, if we increase the number of trials, then the binomial distribution can appear like a normal distribution. And one more point I forgot to mention is, if you see the presentation of the bar graph, here it is, here the gap, there's a gap between the bars because this is discrete data. Unlike in continuous data, if it was a continuous data like in normal distribution, there would be no gap between the bars. Because it is discrete data, there is a gap between the bars. In the previous slide, we saw that keeping the probability same, I had increased the number of trials. But now what I'll do is, I'll keep the number of trials constant, where I'll decrease the probability and I'll increase the probability. So what do I get if I increase or if I decrease the probability? So one with 10% probability, means 0.1, 10% probability, me getting a head, like only 10% chances are there for me to get ahead. So definitely the curve will not be symmetric, and it tends to be asymmetric, and the chances of getting the outcome will be definitely less. So that's why the numbers are being crowded towards the lesser end. And what if I increase the probability to 80%? So 80% chances are there whenever I'm going to flip a coin. So when the probability is increased, the chances of getting the desired outcome, that is getting me ahead, is high. So the numbers are being shifted towards the higher end. So either the probability and the number, both of them will decide the shape of the curve. So as I said, this was a previous slide, again, continuation of the previous slide. So here we had kept the number of trials constant, and we had decreased and increased the probability. So if I want to again turn them into symmetrical distribution, what I'm supposed to do, I have to just increase the number of trials. If I increase the number of trials, even the asymmetric distribution can also turn into symmetric type of distribution. After understanding the role of trials and probability, let us know the properties of binomial distribution. As I said, every distribution has its own unique properties. So similarly, binomial distribution also has its own properties. The first important property is discrete data. It is applicable only to discrete data. The second one is two mutually exclusive outcomes. It has to be two mutually exclusive: head, tail, disease, non-disease, live, dead, so anything. So it has to be mutually exclusive outcomes. Then the shape of the curve depends on probability and number of trials. So usually the probability has to be 50% if at all we want a symmetric distribution. And any asymmetric distribution can be turned into symmetric when the number of trials is made large. The notation again follows this way. For any variable X, like deceased or not deceased, status of COVID patient, so it follows binomial distribution with number of with n number of trials and the likelihood of p outcomes. Some applications of binomial distribution, like whether the drug is effective or not effective, person showing positive results for COVID or not, lab readings, whether normal, not normal, anemic, non-anemic, diabetic, non-diabetic, hypertensive, non-hypertensive. So these are some of the laboratory biological characteristics. When they have discrete type of data, most of the time they can follow this binomial distribution. The last distribution for today's session, Poisson distribution. It is like the same, it's almost like a limited version of binomial distribution. So again, some points to remember it. It is applicable only for a discrete type of data, like that of the binomial distribution. It is applicable for discrete type of data. And the second point is, it is the distribution of the number of times a rare discrete event occurs in a given time. In binomial, we knew that the probability had to be 50%, means the chances of the outcome was high. But when the outcome is less, or it should be a very rare event. So when the probability or the chance of it happening is less, then it follows the Poisson distribution. And here n is not known. So if I compare the binomial distribution where we knew the number of trials, like I knew how many times I'm going to flip a coin, 2 times, 10 times, 100 times. But here in Poisson distribution, it is not known, means the n is not known. So I'll again tell the difference between the Poisson and then binomial distribution. Both are applicable for discrete data. In binomial distribution, the events are not rare. They are like the common one. The probability is high there. Whereas in Poisson distribution, it's a very rare event. And in binomial distribution, n is known, whereas here n is not known. Let us understand this with an example. Number of thalassemia patients attending a clinic between 6 to 7 p.m. Yes, whenever we are saying for Poisson distribution, two things we have to know. The first one is it should be a rare event, and then we have to mention the time period. So, number of thalassemia patients attending a clinic in between 6 to 7 p.m. So, and one more example, number of red cars passing through the toll booth at exact 5 p.m. So red car, again, it's a rare as compared to white cars, 5 p.m. So the time period has been mentioned. So now the rare events happening at a specific time period. So here we can count the possible outcomes, but we cannot have a failed number of events because we don't know how many times the trial has happened. So when it is infinitely large, so we can tell that how many patients have come, but I cannot tell how many thalassemia patients have missed coming to the clinic. I can tell how many red cars have passed through the toll booth, but I cannot tell how many red cars have failed passing through the toll booth. So the outcomes, the possible outcomes can be measured, which is represented as lambda, but we cannot tell the failed number of events in Poisson distribution. So here, when the outcome is less or when it is very rare event, so then it is a Poisson distribution. But as I increase the lambda, means as I increase the rare event, when the rare event becomes so common that it becomes less rare event and then it becomes more common, then the Poisson distribution turns into binomial distribution and it goes for normal type of distribution. The point to notice, when if the rare events continue to happen for a longer duration, or if the number of rare events increases, then the Poisson distribution turns to binomial and then it turns to normal. For example, the best example is COVID patients. So in the starting of whenever we had it in the onset of COVID epidemic, it's a pandemic, then when it started, we had very few count of numbers, like we had 1 patient, 2 patients, 3 patients. So that was a Poisson distribution. Very rare event happened. And after some time, the number of patients increased. So it became so common that everyone were like COVID positive. So it turned into binomial and then it is normally distributed in the whole population. So that is how Poisson distribution continues to become binomial to normal distribution when the rare events becomes less rare and becomes common. Characteristics of Poisson distribution, 4 important points to note. The first thing is it should be a rare event, and then event means it should be a discrete data. It should happen in a fixed interval, and the occurrence of the events must be independent of each other. Like, for example, that red car passing through the toll and the next red car passing through the toll, it should not have any relation. There is no relation at all. One thalassemia patient attending a clinic and the second thalassemia patient attending a clinic, there should be no dependence with the occurrence of the events. So these are the 4 points: rare event, discrete data, fixed interval, and then there should be independence in occurrence of each event. Examples, like average rate of accidents happening in a year, or defect rate in the vaccine lot, natural disasters happening, supply demand chain predictions, like mask supply and demand chain. That before we never, I mean, the demand of the use of mask was less, but after that it increased. So we cannot predict what is happening. So this type of events we can see that the Poisson distribution is followed. Let us see this with one example. So the number of deaths happened due to lightning in the last year was 7. So the deaths that has happened in the last year was 7, means lambda is 7. So my question is, I want to know how many, what is the chance that 4 deaths will happen due to lightning this year? So in the last year, 7 deaths have happened, but now this year I want to know what is the chance that only 4 deaths can happen, deaths can happen due to lightning in this year. So this is a formula what we use for Poisson distribution. So lambda is 7 and x, we want to know about 4 deaths, and we have a nearest constant. So when we apply these numbers in the formula, we get this 9.13, means there are 9.13% chance that there will be exactly 4 number of accidents that can, deaths that can happen because of lightning this year. Now we have understood about normal, binomial, and then Poisson distribution. Let us move to the last section of the session, MCQs. I hope everyone might have solved this. This will be a revision again. So the first question is, all of the following are examples of nominal scale except. So age is a continuous one. So definitely this is the answer. Gender is a nominal, boy, girl. Religion, yes, it is nominal again. Race, again nominal. So the answer here is age. So this is a continuous type of data. Second question, when frequency is given as mild, moderate, and severe, yes, that there's an order. So definitely the data used here is ordinal type of data. Third question, best way to show relationship between two variables. So when we have two variables, then we have the scatter diagram as the best one. We cannot, it has to be actually two continuous variables. So bar chart, pie chart is used mainly for qualitative data, histogram for continuous. Scatter plot helps us in understanding the relationship between two variables. So scatter diagram is the answer for this question. Fourth question, a pictorial diagram of frequency distribution of quantitative data is denoted by. So quantitative data. So bar chart, qualitative data. Pie chart, qualitative data. Histogram, quantitative data. Line graph is time frames. So the answer is histogram here. The percentage is depicted by, so as I said, whenever we are plotting a pie chart, so the data has to be converted to percentage. So the answer here is pie chart. Now, I think everyone will be answering this question. A normal distribution curve depends on mean and then standard deviation. Mean tells us about the position, whereas standard deviation tells us about the spread of the normal curve. True about normal distribution curve is all except mean, median, and mode coincide. Yes, they all coincide. Total area of the curve is 1. Yes, either 1 or 100. Standard deviation is 1. Yes, it is 1. Mean of the curve is 100. No, mean of the curve will be 0. So the answer for this question is mean of the curve is 100. It's not 100, it should be 0. The probability of two mutually exclusive events is given by. So two mutually exclusive events, definitely it is binomial, not normal distribution, because normal distribution for continuous. Poisson distribution is very rare event. We cannot tell the predictions. Exponential we have not discussed. So the answer here is binomial distribution. All are characteristics of binomial distribution except. So applies to discrete data. Yes, it applies to discrete data. Each observation is dependent. No. Here, even like that of Poisson, the observations are independent. Symmetric curve when probability is 50%. Yes. So binomial distribution curve has a property. When we have a probability of 50%, the curve tends to be symmetric. Each observation represents one of two outcomes. It's a binomial observation what we get. So the answer here is each observation is dependent. It should be independent. Last question. All are characteristics of Poisson's distribution except. Applies to discrete data. Yes, it applies to discrete data. Each observation is independent. Yes, they are independent. Applies to rare event. Yes, it applies to rare event. When it becomes common, then it becomes binomial distribution. The events does not occur in a fixed time. No, the event has to occur in a fixed time. We need to fix a time whenever we are telling about Poisson distribution. Hope the session is clear. To summarize, biostatistics is a specialized branch which mainly deals with the numerical facts related to biological sciences. And then the type of data is very important to be known, qualitative or quantitative. Presentation of the data can be done either of the three methods, text, tabular forms, or the diagrammatic form. And distribution of data, depending on distribution, we have three major types of distribution: normal distribution, binomial, and Poisson distribution. Each one of the distribution has its own characteristics and properties. Thank you. So any doubts, please let me know in the chat box.
Thank you so much, Dr. Asha. We haven't received any questions or any comments till now in the chat. I've been monitoring it on the other side as well. But thank you so much. I think this has definitely been able to give some kind of overview as well as insights into some specific issues, including presentation of data and also about the basic concepts in biostatistics, as the title of the session was aptly named. And let's see that this is meaningful. I'm just observing and I'm just waiting to see if there are any questions in the chat. However, there are none as of now.
No, sir, we haven't received any questions.
Exactly. So if there are any questions, participants, you may put in. I think we had more than 100 people at one time. I had seen 117 people. I don't know how much right now. Also 102, 103. So that's good. At least quite a few viewers today. And this will be archived later in the YouTube channel of IAPSM Karnataka. So you can always revisit, or you can ask your friends to catch up with. But this being a live session, I would urge you all to take advantage of this forum to put in a question if you have, or you want to seek a clarification, you could do that. Dr. Asha is available with us, so we could do that. So meanwhile, Dr. Asha, so the advanced, that is the next part of it, which will be in the next month, we will be covering more advanced. You could just give a kind of, maybe a glimpse, just to, make participants understand that what's in store for the next one.
Yes, sir. Actually, I wanted to put sample size and sampling also in the session, but thought it would be more. So definitely I'll be covering that sample size, because most of the PG students or first year residents now, they have this main question when you're selecting the dissertation topic, like what is the sample size should be and how to select the sample. So that will be covered, and mainly about inferential statistics, descriptive and inferential statistics, like how the tests have to be selected. Like as I said, mainly depends on the data. So in this session, I've just briefly told about types of data. So in the next session, definitely it will be covering on how the test should be selected and what type of test should be applied based on the objective and also based on the type of data. So two important points that will be covered in the next session.
Right. So I think that would be also very useful, and from the practical point of view of application, where they can apply it in their dissertation or any other thing that they do, I think that would be very important as well. So we will announce the date subsequently, but it will be sometime in December. So yeah, I think that should be fine. Right. I don't think there are any questions. I'm monitoring it. So Ruksha, anything?
No, sir, we haven't received any questions yet, but we have received comments like thank you comments and all.
All right. Okay.
Yeah, and one more request to all the participants, like as I mentioned that I'll be covering sample size, sampling methods, and statistical tests. If you want me to focus on any other important point under statistics, please let me know in the chat box so that I can even cover if at all time permits me that.
Right. So I think then it's almost time to say, goodbye. So before that, let me thank Clarnet and Ruksha and Sangeeta.
Thank you, sir.
Yes. So for this support and digital partner of ours, and we hope that this partnership continues. I also thank IAPSM Karnataka chapter, Dr. Poonam, as well as Dr. Sunil and others in the team to have given us this opportunity. We look forward to seeing you all again next month when we come with the second part of this. And till then, I think take care. Have a good time. Thank you. And thank you, Dr.
Thank you so much, everyone, for extending us the opportunity to host the session. So with all your permission, I would like to sign off here and looking forward to host you again. Thank you.
Thank you.